Good evening. My name is Austin Brister. This is my final presentation for the History of Philosophy Sciences LS2301 class held by Ryan Miller. This is my final presentation on chemistry. Thank you for your time. So, before I get into anything, I want to just explain the key theories and players that I will be looking at during this presentation. So, over here on the right, on the bottom, I have a picture of Democritus, and on the top, I have a picture of Aristotle. Just really quick. I do have my own slide for these players, but there's enough information on that slide and just the way that I set everything up. I don't want it to be too crowded, so I just went ahead and put these players right here since they're kind of common and we already kind of know what they look like and we kind of already know some stuff about them. So first theory I'm looking at is the phlogiston theory of George Ernst Stahl, which was worked on for many years and became the popular belief at his time, which then after Antoine came along with his theory of combustion, which he's also known as the father of modern science in modern day terms. So Aristotle and Democritus, we obviously know Aristotle. Now Democritus was another philosopher near the time of Aristotle who thought about his theory of atoms. So now that I have everything laid out, here's the rest of my presentation. So starting off, we have George Ernst Stahl. So, Stahl created his theory of phlogiston. He essentially assumed that in a combustion reaction, uh, the substance that would burn then squeeze out phlogiston, which was a make kind of a make-believe substance. He didn't People at his time, including him, did not know that oxygen existed or that hydrogen existed. So whenever he had theory, his theory was based off of oxygen, although he did not know this. So he called it phlogiston. Now, a major problem with this was that he had no way to explain the weight distribution between the reactions, so the reactants to the products. So his product, aka calx or phlogiston, weighed more than the original metal that was used in the reaction of combustion. So this was the biggest caveat of the time, but he had so much influence and his theory came out so well that a lot of people actually believed this at the time. So now on to Antoine Lavoisier. Actually, I would like to look at this picture again. Behind him is actually a little setup of his combustion. This is a picture that I found. It was a very nice picture. Now, so going into Lavoisier. So he theorized that when two molecules combust together, they have a release of energy, heat, and light, which we all know. And you can also end up with a colorless, odorless substance, which he named oxygen later on, which was based off of this quote right here. Excuse me. All right. So Lavoisier, through some tests and experiments and his own little combustion setup, he designed a way to actually realize that when substances burn, they gain weight, and the weight they gain is precisely equal to the weight lost by the surrounding air in the reaction. Now, if you know anything about chemical reactions and whatnot, especially thermodynamically favored ones, you know that the energy in the system needs to equal, or the energy in the universe of the system needs to equal zero. Although the energy in the surroundings could be greater than zero, or the energy lost could be less than zero, anything like that. But it needs to all equal zero for it to be an actual reaction. Now, weight, same thing. And we go back, George Ernst Stahl had no way to actually determine what was actually happening based off of his reaction. He just assumed that phlogiston was a thing. And then obviously we don't. We don't assume. So this goes on to the combustion theory perfected. Now, Lavoisier, well, I would like to look at George wasn't too far off, but Lavoisier just took his theory and kind of refined it a bit. This was kind of the setup that Lavoisier used. You burn something on the bottom right here. The air flows up through A, and it flows into about E right there in the tank, and then it gets weighed, so you know what you have. So Lavoisier's theory of combustion recognizes the discovery of hydrogen and oxygen as new elements that he discovered. So based off these tests that he did and the data that he came up with, the new common belief between the scientists of that era was that combustion produces oxygen and energy in the form of an explosion or fire. Although phlogiston was good, Lavoisier just refined it a bit. Not perfected it, it's fair to say, but he did not debunk the theory of phlogiston. Phlogiston wasn't that far off, but there was just a better way to explain it. So on to the other side of the arguments. So we have philosophy and old chemistry. Okay. We all know Aristotle. We've learned about Aristotle for many, many years, but we haven't really learned like too much of the science part until this class. So I would like to say just Aristotle kind of believed that the world was made up of qualities that could not be reduced or tampered with, which just like his example of the four elements. He believed in only four elements that actually existed. Obviously, we have like 100 plus right now, right? But Aristotle believed that elements were combinations of qualities, not actually like actual things. Like, I don't know exactly what this is made of, but if we had carbon, or well, carbon's the best element ever. But if we had any other element, Aristotle would look at it and be like, that's not an element. That's that's just a I'm sure an element's made that, but that's not an element. So qualities like hot, cold, dry, were qualities of elements. So fire, earth, water, ice, or fire, earth, water, air, stuff like that. Now, Democritus, who was around the time of Aristotle, actually believed in matter being made up of indivisible particles that were all shapes and sizes, and they were not only spherical. Now, that is very important to say they were not only spherical because Aristotle kind of believed in the whole sphere, like everything's a perfect circle, like like the orbit of the planets around Earth because he was very geocentric and whatnot. And Democritus also believed that the change of the macro level was based on the coming in together of the entanglement of atoms. Now, why why did nobody believe in Democritus, even though Democritus wasn't that far off from the actual, the theory that is believed today, even though he was thousands of years ago? So the reason of this was that at the time Aristotle had undeniable influence, just immense influence on the popular belief on kind of how everything works. So when Democritus kind of proposed the impossible theory of, you know, things like people, objects, anything and everything being made of subatomic particles such as atoms, no one believed him because in that time frame nobody could grasp the concept of subatomic particles. So when Aristotle kind of made him out to be like this crazy guy, he just lost all of his what was it? All of his influence, anything he had, all his respect and responsibility. Yeah, lost all of it. And even though his theory was somewhat correct, Aristotle shut it down. So all of this to say that I would like to discuss a little bit before we conclude this presentation. So philosophers once called the term science natural philosophy, which just goes further to say that we would not have theories if it were not for philosophy. We would not have scientific theories per se. So philosophical ideas are the foundations for the ideas and experiments that future natural philosophers use in their research to shape the world over time, aka the ones that were just discussed. Aristotle, Stahl, Antoine, and Democritus were all philosophers in their own right. So the point to unfold is that chemistry and philosophy are dependents of one another, although you can have philosophy without chemistry, although you cannot have chemistry without philosophy. The chemical discoveries throughout history all had inspiration from a philosophical view of chemistry from a prior philosopher, and then just got refined from a brilliant person that created a new theory. Now, to conclude, the challenging philosophical views of each philosopher with each scientist over the past 1,000 years were not meant to argue against each other. Instead, these ideas were meant to perfect the last one or to refine the last one. Because even though they were refining them, some of them are not perfected. Well, actually, most of them aren't. So each time a scientist kind of came out with a new theory, another scientist after them would decide, or they'd be on the same track, and then they would look at it and be like, "Oh, I see a caveat here. I see an issue there. Maybe we can like test this and figure this out." And that's kind of how we as a civilization have grown because people are very curious. So they'll just look at something and they'll say, "Oh, this could be fixed. I'll try to fix it." And that's essentially how things end up being discovered, how theories are born, and how old theories are, while they're not technically wrong, they're built off of and then expanded with. And that is what I believe is the essence of this class. Even though I used to assume that all of the philosophers that we're looking at for the first couple of readings were not building off each other. I assumed that they were just trying to correct the last one, and that they was all it was all an issue with each other, and I assumed that they were trying to debunk the theories of the last philosopher. Now, I believe that now I'm very wrong about this, and that the philosophers that we've studied in this class so far were not meant to do such things, and were rather just to show you the history of how our scientific theories have been built. Now, with that, I conclude my presentation. Thank you for your time. Thank you for this class. Have a great one.